Hello everyone. In this video we'll be working with quadratic relations. We would like to determine the vertex, we'd like to determine the axis of symmetry, and we'd like to determine the maximum or minimum value for the quadratic. And we're going to focus on a technique called completing the square. So we begin by taking the equation and we're going to bracket the first two terms. Then we're going to take the a value, which is -5, and we're going to make that a common factor and divide it out of the brackets. And the first term divided by -5, and we common factor the second term as well, divided by -5, and the +2 remains on the outside. So when we simplify this, the -5 divided by -5 leaves us with x squared, and the +30 divided by -5 leaves us with -6x. Close the bracket, and the +2 remains. So we're going to pause for a moment, and we're going to talk about completing the square and what that means. So if we consider, and I'm just going to take the inside of the brackets for a second, and we're going to talk about that. X squared minus 6x. And in standard form, complete standard form, we're going to have another term here, a constant. And the middle term, the coefficient is -6. And on the first term, the a value, the coefficient is 1. So when a is 1, if we took half of b, so -6 divided by 2, which is -3, and if we square that value, so -3 squared, that equals 9, then this trinomial, which right now is not complete, becomes x squared minus 6x plus 9. And this is how you complete the square. And what does that mean, complete the square? Well, to understand it better, if we would factor this standard form, x times, and we use product and sum, x times x equals x squared, and -3 times -3 equals +9, which means our factored form would be x minus 3 times x minus 3. So notice both factors are the same. So in other words, the trinomial x squared minus 6x plus 9 is a perfect square trinomial. Perfect square trinomial. Squish that in there. So in other words, we could write this as x minus 3 squared. So we have perfect square trinomial. We have perfect factors of x minus 3 squared. So that is the background to the idea of completing the square, because recall that +9 didn't exist inside the bracket. Inside this bracket, there's no +9. So we're going to complete the square. We're going to create the perfect square, and as such, it'll turn this quadratic relation that started in standard form into vertex form. So let's continue. I'll go back to blue, and then the blue will be the sequence of completing the square, and the red and the green is the side lesson on what it means to have a perfect square trinomial. So our next line, and maybe we'll number our lines, so line 1, line 2, line 3, and now line 4 of our solution is -5 bracket x squared minus 6x. And recall the 9 would complete the square, but the 9 doesn't exist. So how do we show it, but at the same time continue with the fact that it doesn't exist? It has to, line 4 has to equal line 3. So the way we do that is by adding it and subtracting it. So technically 9 minus 9 is 0, it's not there. And the plus 2 remains on the outside. Now we have completed the square, but we want the perfect square trinomial to remain in the brackets, which is what I just underlined. The negative 9, the subtract 9, is not part of the perfect square. So how do we allow the perfect square to remain, remove the negative 9? The way we do that is by using the distributive properties. We're going to multiply this negative 5 by the negative 9, and as a result, the negative 9 is no longer in the brackets. So negative 5 brackets x squared minus 6x plus 9. The negative 5 multiplies with the negative 9, which removes it from the bracket, and it becomes positive 45. So like I said earlier, we completed the square by adding 9, but technically it doesn't exist, so we had to also subtract 9. And that's the little algebra trick to complete the square and not alter the equation, because all these 5 lines need to be equivalent expressions of the original quadratic. So let's continue. So in line 6, the negative 5 remains on the outside of the bracket. We can factor the inside of the bracket. It's a perfect square trinomial. The perfect root that we're going to use, b divided by 2 value is negative 3. And we previously noted that it becomes negative 3 squared. So we could show it as negative 3 squared. And the plus 45 plus 2 becomes positive or plus 47. And in the 6 lines, we have not only completed the square, but we've expressed the quadratic in vertex form. Vertex form. We started in standard form. Which is y equals ax squared plus bx plus c. Recall that the a value tells us the direction of the parabola. If it's positive a, then the parabola is going up. And if it's negative a, then the parabola is going down. And the c value is our y-intercept. So those are the benefits of standard form. But now we're going to continue understanding the benefits of vertex form. And that was the whole point of completing the square, because when it's in vertex form, in general, it's y equals a bracket x minus h squared plus k. And the a value takes on the same meaning. The positive a opens up, the negative a opens down. But the h value, in this case h is 3, becomes our axis symmetry. And so the axis of symmetry, where this parabola is symmetrical, is x equals 3. And the k value is 47, and that becomes our maximum value. That's the, since it's a is negative 5 and the parabola is opening down, then k is a maximum value. It's the highest y value. So putting this all in perspective, what is the vertex? Because the original question, 2a, asks for determine the vertex, and we're determining that by completing the square. Then part B wants the axis symmetry, and part C wants the max or min value that we've just answered. So let's label our answer accordingly. Here is the answer to 2b, and here is our answer to 2c, And then the original question wants the vertex. So we take h, which is 3, and we take k, which is 47. And in general, our vertex is h comma k. So in this case, our vertex is 3 comma 47, period. And let's put this in perspective. Let me just shrink this down a little bit. If we draw a sketch, and at 1, 2, 3, and let's just jump up to 47, that is our vertex. And because a is negative, the parabola is going down. So notice the maximum y value possible is 47. And notice that this y value occurs when x is negative 3. Is positive 3. And notice that this positive 3, if you make a vertical line through positive 3, that is the mirror that makes the parabola symmetrical on the left and the right side, which is why it's called the axis of symmetry. And that's why 47 is the maximum value. It's the highest point on the parabola, and that highest point occurs on the axis of symmetry, which is x equals 3. And together, that's why the vertex is 3 comma 47. So, big picture, we were given a quadratic relation in standard form, and the goal was to determine the vertex, the axis of symmetry, and the maximum value. And both these answers are inside the vertex. And we use the technique called completing the square to determine the vertex. So what is completing the square? Now that we have it all written out, let's review it. We bracket the first two terms. We common factor the a value out. That leaves us with a simple trinomial in the bracket. Then we consider that b is negative 6, that half of b is negative 3, and half of b squared is 9. And by adding 9, we complete the square and create a perfect square trinomial. And then recall that the 9's not there, so we have to add it and subtract it to create the illusion that it's there, but also not there. And then by multiplying the negative 5 by the negative 9, we can remove it from the brackets, and the multiplication becomes positive 45 on the outside of the bracket, which with the positive 2 leaves us with positive 47. And by factoring the perfect square trinomial, we have x minus 3 squared, which puts this standard form into vertex form in general. And that concludes this video on determining the vertex, determining the axis of symmetry, and determining the maximum or minimum value, in this case a maximum value since a is negative. Thank you for watching this video on completing the square in the study of quadratic relations. Please subscribe to the channel for more notifications when new videos are created. And if you like the video, click the like button. Thank you. Have a great day. You guys are awesome. Take care. Bye-bye.